Hi, my name is Mariko Shaw, and I am a fourth year mechanical engineering major here at the University of Georgia. And this year, I am currently serving as the Society of Women Engineers Vice President of Outreach. So, I'm going to tell you a little bit about mechanical engineering, which is the study of objects and things and processes and how they work in our world. So, this would be learning how a car works or how a medical device like a needle that helps deliver medicine that's really important in people's lives works. So just we have a really large spectrum of things that we can do and have our hands in a lot of different pots that affect the world around us. So I'm going to be talking about a really famous mechanical engineer named Mr. Lonnie Johnson. This is Mr. Lonnie Johnson. So as you can see in the picture depicted, that he is holding a super famous toy, which is the Super Soaker, the squirt gun, the water gun, as we modernly know it. So Mr. Ron Johnson is actually the inventor of the squirt gun. He created his patent in 1986, as you can see here, and it wasn't exactly what he was originally designing, but through his tinkering and his invention skills and the skills that he developed from his mechanical engineering major, he was able to come up with this invention. Mr. Lonnie Johnson, originally got his mechanical engineering degree from Tuskegee University, and he later got his master's degree in nuclear engineering as well. He worked at the Air Force for a couple of years and then later worked at NASA from 1979 to 1991. And this is where he was able to create his first patent. Mr. Lonnie Johnson currently has 121, no, 120 patents in his name that are famously used across the US and around the world. Probably most famous outside of a squirt gun is the Nerf gun, which I know a lot of people have seen and used and had a super great time with. So, this is my brief lesson about a very famous mechanical engineering major who has had a lot of influence across our lives. Thank you.
Hey everyone, my name is Christopher Johnson. I am a mechanical engineering student at the University of Georgia College of Engineering. Mechanical engineering gets to basically take all the math and science skills that we learn in the classroom and apply them to different machines out in the real world. If your parent or grandparent drives a car, takes an airplane, different subway systems across America, a phone, a laptop, things like that, a mechanical engineer has worked on them. My favorite part about mechanical engineering is that I get to basically design or construct devices that I can then use in my day to day life.
Hey everyone, I'm Amy Beth Lee. I'm a mechanical engineer at UGA and I'm part of the Society of Women Engineers. And today I'm going to talk to y'all about why engineers like support. So first, what's an engineer? An engineer is a person who applies science and mathematics to solve complex problems through designs and ideas. So an engineer can land rovers on Mars, construct large bridges, design a fun roller coaster, build innovative robots. There's a lot of things and a lot of different engineers. And I'm going to focus on more of the physical side, so more of like building, hands-on, wheels, gears, tools, that side of engineering. But there's also different types of engineering where it's chemical or based on life sciences or environmental, where they construct and design turbines to create energy powered by wind, or even building prosthetics for people who don't have arms or legs or anything like that. So, what is one thing that these creations have in common? They have support. So what is support? A support is something that bears weight or keeps an object upright or stable. So as an example to show y'all what support is, I have a roller coaster. So the roller coaster has all its weight bearing down on each of these pillars. And these pillars are going to try to push back up on that weight to make sure that this roller coaster doesn't move, doesn't fall, doesn't sway in the wind, doesn't do anything like that. And it ensures that design of the roller coaster is stable. So just to reiterate, or just say again, the forces down are equal to these forces that are pushing back up on the pillar. So why do engineers need support? Because everything needs support. So support ensures that the structures are stable and don't move or break from its position. So an example of this at home is the chair that you're sitting in, or the desk or table that you're working at. Those legs on the chair or on the table are pushing back up to support the top of the table, so to make sure that the top doesn't fall down to the ground or that you and the chair don't fall to the ground. So another example of this is actually right here in Athens at Sanford Stadium. They build large pillars like this near the snacks and concessions to ensure that all these people, all their weight that they're pushing down on the concrete is actually supported, so they push up equally as the forces of the weight pushing down to make sure that the bleachers are still the same height and they don't fall to the ground. Another example is in Atlanta with all the skyscrapers, so they have to have good internal support to make sure that the floors don't fall, that they're able to actually reach these 100 floors and everything like that. So now, would you believe me if I told you a piece of paper can hold a tower of books? I'm going to show you today how we're going to make a paper book tower. The first thing that you need to do is grab you can grab multiple pieces of paper. Grab some paper and tape. This can be any kind of paper, so computer, construction, notebook, anything. Even if you've written on it or drawn on it, as long as you're allowed to use it, you can use it. Second thing you need to do is lay the piece of paper on a table or any flat surface. Then begin rolling from the bottom of the paper to the top. You want to make sure that you start from the shorter side. And then keep rolling until you have a paper tube. And then, to make sure that the paper tube doesn't uncurl and flatten out again, you need to put a piece of tape in the center of it. Now you have a paper tube. So in this example that I made 4 paper tubes, and I began with 1 book. So you see the weight of the book is equal to the force that's pushing back up on it. So these forces are equal. So it's not going to move. And then I added 4 more books for a total of 5. So you have this bigger force pushing down from the weight because it's so much heavier. And then you have an equal force pushing back up. And now I have 7 books that have an even greater mass pushing down, a greater force pushing down, but the paper still makes the same force pushing back up until I added one more book and the force was too great and crushed the paper. Now, when you're working on this at home, you can start thinking like an engineer and explore more about the support of the paper tubes. So you can experiment to see if less tubes used are stronger than more tubes, or more tubes are stronger than less tubes. And you just see like how many books one can hold more than the other. Then another thing that you could try out is actually the shape of the tubes. So do circular tubes hold more books than triangular, or do triangular tubes hold more than square tubes? Another thing that you can also try is, does the type of paper that you use make the tube stronger than other types of paper? So do construction paper, can they hold more books than notebook paper? That kind of thing. Another thing, what have we learned from this? So we've learned that support is used to help create stable structures. They're having equal forces, so the downward mass and everything, the downward force is equal to the upward force. And that engineers use this in just about every design in order to hold large structures like buildings or even a small table or desk. And another thing that we've learned is actually you can take this design of the paper tubes and actually experiment to see what's the best design. Is it a small 2-inch square tube? Is 6 of them better than 2 of them? You're able to explore and think like an engineer. So thank you for learning about engineering today, and go dogs!